Hello friends, welcome back to my Rashid Iqbal channel. In this video, I will explain the lighting protection system step by step in clear, simple with easy example. So before we start the calculation, let's first understand the four main part of the external lighting protection system. Number 1, air terminal. These are rods or conductors installed at the highest point of the building, usually on the roof. Their main job is to capture the lighting strike safely before it can hit the building itself. Number 2, down conductor. Once the strike is captured, the current need a safe path to travel down. That is the role of down conductors. These are metallic strip or cable that connect the air terminal to the ground. Earth termination system, or we called earth pit. This is the final stage of lighting protection system. Here the lighting current is safely discharged into the ground. The main idea is to spread the current into the soil smoothly. Fourth one, SPD, that is surge protective device. Even if air terminal and earth pit protect the building from direct lighting strike, still electrical surges can travel through a power line, that is phase, neutral or earth. Even though through data and communication cable, these surges can damage sensitive equipment like computer, UPS or servers. To protect them, we can use surge protective device. So if you want a detailed video on SPD, please comment below. I will make separate video explaining SPD in full detail. So together these four parts make sure the lighting energy is captured, carried and released into the earth in a controlled way, keeping the building and equipment safe. Now we will learn how to design a lighting protection system. There are three standard methods we use. I will explain one by one through a simple diagram. The first one is the rolling sphere method. Second one, protective angle method. And the third method is mesh method. So first we will learn about rolling sphere method. Imagine a big sphere rolling over the building surface. As you can see here, this is a sphere which is rolling over the building. So wherever the sphere touches the roof or a structure, that area is unprotected. As you can see here, this sphere is touching the roof surface. So that part is unprotected. And wherever the sphere does not touch, that area is fully protected. So our job is to place air terminal so the sphere cannot touch any important surface. For example, here you can see the sphere rolling on the roof. At this section, the sphere is touching the surface, which means this area is unprotected. If we install another air terminal rod between the two rods, the sphere can no longer touch the surface. You can see here, now it is not touching the surface. So this part becomes fully protected. You can see here, this green highlighted area is fully protected. On other side view of building, the same procedure applies. Even a smaller structure on the roof will also be protected if the sphere does not touch them. Now the question arises here, how do we know the radius of the rolling sphere? The radius is not a random number actually. It is defined by International Lighting Protection Standard like IEC 62305. Actually, the radius depends on lighting protection level. We can say LPL. You can select for your building. There are four protection level 1, level 2, level 3 and 4. Each level has different sphere radius. Let me explain. Level 1, the radius of a sphere is 20 meter. That is highest protection used for very sensitive or dangerous site. Level 2, radius is 30 meter. Level 3, radius is 45 meter. And level 4, radius is 60 meter. This is the lowest protection used for normal building. So if you are designing for a residential or commercial building, usually we can use level 3 or 4, meaning the sphere radius will be 45 or 60 meter. This radius tells us how far the lighting can reach the surface. By applying this sphere on the building, we can easily identify which area is protected and which are not. Let's take one example so you can understand clear. We have a building with this dimension. Building height is 45 meter, width is 35 meter, length 65 meter, and here I am going to install air terminal which height is 2 meter. So in this building I am going to use level 2. This is for medium risk, and for the level 2 the rolling sphere radius will be 30 meter as I explained earlier. So first we need to calculate maximum spacing, means maximum space between two terminals. Why do we need this? Because if two rods are too far, then the rolling sphere can touch the roof, leaving some parts unprotected. So the maximum spacing tell us the safe distance between rods, means how maximum space we can keep between two rods. Then second, we need to find out required number of air terminals. Once we know the maximum spacing, we can work out how many rods are needed along the length and width of the roof to cover the entire parameters and surface without gaps. And third thing we need to find out, that is penetration height. Between two rods, the rolling sphere dips down. Penetration height tell us how deep it dips at the midpoint. So let's start the calculation. We have to find out maximum spacing. First, let's calculate the maximum spacing allowed between two terminals. So the formula is d max equal to 2 multiplied by root under 2 multiplied by h multiplied by r minus h square. Here h is the height of a terminal, which is 2 meter. R is the rolling sphere radius, which is 30 meter, and d max is the maximum spacing between two terminals. Now let's substitute this value into the formula. D equal to 2 multiplied by root 2 multiplied by 2 multiplied by 30 minus 2 square. So after solving this equation we get 21.54 meter. So this is the maximum spacing allowed between two air terminal is 21.54 meter. This is the maximum spacing allowed. That's mean whenever we place rod on this building, we must make sure the distance between them is not more than 21.54 meters. Otherwise, the roof area between them will remain unprotected. Now second, we need to find out the numbers of terminal, air terminal. So the terminal along length, as we know, the total length of building is 65 meter. We already calculated the maximum spacing allowed between rods, which is 21.54 meter. Now if we divide the length 65 by 21.54, we get 3.01. That's mean the length side of the building must be divided into 3 equal segments. To make 3 segments, we need 4 rods. Here you can see there is 3 segments here by installing of 4 rods. So on one long side of the building, we place 4 air terminals. Since the building has 2 long sides, the total rod become 2 multiplied by 4, that is 8 rods, 4 this side and 4 opposite side. Let's move to the shorter side of the building, which is 35 meter. This is the width of the building. If we divide 35 by 21.54, this is the maximum allowable distance, then the result is 1.62. This means we need at least 2 segments here, and to make 2 segments we need 3 rods. So on one short side 3 rods are required. Since the building has 2 short sides, the total rods become 3 multiplied by 2, means 3 this side and 3 opposite side. So 3 multiplied by 2, 6 rods. Now let's add them together. From the long side we need 8 rods, and from the short side we need 6 rods. So the total rod become 14. But wait, for 4 corner rods are common to both long and short sides. That's mean they were continued twice. So we subtract 4 rods, and then the final total is 10 air terminal. Because these 4 rod is common, So we just reduce this 4. So the total rods required for this building is 10 air terminal, 10 rods. Now let's calculate the penetration depth of rolling sphere between two rods. The formula is P equal to R minus root under R square minus D by 2 whole square, where P is the penetration depth, R, this is the radius of sphere, and D is the maximum distance. So let's substitute the value in this formula. So it become equal to 30 minus root under 30 square minus 21.54 divided by 2 whole square. After solving this, we get P equal to 2 meters. This means that the rolling sphere dips 2 meter downward between two rods. Now, since our rod height is also 2 meter, the sphere just touches the tip of the rods. So the roof is protected, but only at the minimum level. This is the warning point. If there is something like tank, HVAC unit or solar panel on the roof, they will not be covered. Even a person standing there will be outside the safe zone. He will not be protected. So what is the solution?
Now when it comes to improving lighting protection, we have two main options. Option 1. Reduce the spacing between rods. If the rods are closer together, the imaginary rolling sphere cannot dip as much in between them, which means the roof gets better coverage. Option 2. Increase the rod height. If you can buy a taller rod, that's great. It will give you more protection. But if you want to save cost, then there are a practical way to increase the height without buying a new rod. First you can do, place the rod on top of the parapet wall. This effectively increases the height without changing the rod itself. Otherwise, use a concrete block below the rod to raise its height. For example, if we increase the rod height to 4 meter, but the penetration depth of the sphere is still 2 meter, then the effective safe height is rod height minus penetration depth. So 4 minus 2 equal to 2 meter. That's the actual protected height. So what does this mean? It's mean now everything up to 2 meter high on the roof, like small equipment, tank or we can say people, they will be safe inside the protection zone. So by either reducing the spacing between rods or increasing the rod height, we can make sure that the roof and all the equipment on it are fully protected from lighting strikes. Now let's understand the angle protection method. Imagine you have one lighting protection rod installed on the roof. This rod doesn't protect in a straight line. Instead, it's protect in the shape of a cone. You can think of it like an umbrella turned upside down with the rod at the center. This cone is spread all around the rod in full 360 degree. So what does this mean in simple words? It means that any part of the building or equipment that fall inside the cone is protected. But if any part of the structure goes outside the cone, that part is not safe. That means lighting can still strike there. Here you can see one side of the house outside the cone. That part is not protected, which means a single rod is not enough. Another example, if we install only one lighting rod on the large roof, that rod will create only a small cone of protection. Most of the roof will still remain unprotected. That is why in real project, we must carefully calculate the protection angle and coverage area. Only then we can decide how many rods are required and where they should be placed to protect the entire building. Now let's move into the calculation. In our example, this is the building. Its height is 13 meter. And we are planning to install rod which length is 2 meter. Rod height is 2 meter. So the total height equal to 13 plus 2 equal to 15 meter. This 15 meter is the effective height for our protection angle method. If we are calculating protection for the ground level around the building, then we consider total height, that is building plus rod height. Why? Because lighting always strikes the highest point. So for ground protection, lighting sees both the building height and the rod. If the rod is installed on the roof and we are calculating protection for the roof itself, then we consider only rod height. I'll explain you later. Now let me draw a triangle based on this height. Here AB is 15 meter, which is total height including roof and rod. So we have total 15 meter height. Now we need to find out the protection angle from the catalog. So let me open catalog. Here you can see from the catalog for 15 meter, the protection angle is 45 degree. This is the protection angle for 15 meter. If we have different length, then we will use different protection angle. But here our length is 15 meter, so we will go with 45 degrees. Using trigonometry formula, tan theta equal to opposite divided by adjacent. Here the opposite side is BC and the adjacent side is 15 meter. This is the adjacent side, that is 15 meter. Now the angle theta is given as 45 degree. This is what we get from catalog. So we can write here tan 45 degree equal to opposite, this is the BC, divided by 15. So tan 45 degree is equal to 1. If you calculate tan 45 degree, so you will get 1 equal to BC divided by 15. 1 equal to BC divided by 15. So after solving this equation, we get BC equal to 15 meter. That's mean the length of side BC is exactly 15 meter. So the protection radius at ground level is 15 meters. That's mean any person or object within 15 meter from the building foundation is protected. But if anyone is standing outside this 15 meter radius, they are in danger zone. Now let me calculate protection on the roof itself. Here we only considered the rod height, which is 2 meter. Why? Because the roof is already at the top and we only need the protection length of the rod on the roof surface. So let me again from a triangle. Here AB is 2 meter. Now let me check catalog again. From this catalog, we have 2 meter length. So the angle is 73 degree. I will take angle 73 degree. Let me apply in this formula. Tan 73 equal to opposite. Here we have opposite is just BC and adjacent is AB. So AB here is 2 meter. So let me put here tan 73 equal to opposite BC. Opposite, this is BC divided by 2. After solving this tan 73 degree, we get 3.271 equal to opposite BC divided by 2. So after solving this equation, we get opposite this the length of BC equal to 6.54 meter. So the protection length on the roof is 6.54 meter. That means the rod protected only 6.54 meter in all direction on the roof. Same calculation we will apply in that side, this opposite side, because the length is same, angle also same. So the protection length also same here, 6.54 meter. As you can see, this does not cover the entire roof. Still a large portion remains unprotected. So what is the solution? In that case, we have two options. Either increase the rod height so that the protection cone become larger, or increase additional rods. For example, If we add one more rod of the same height in the center, then each rod gives 6.54 meter protection. These cones overlap and cover a wider area. If we look at the top-down view of a wide roof, we can place 3 rods side by side. Each rod creates a circular protection zone of about 15 meter as we calculated earlier. So based on that calculation, let me cover here. 15 meter is the diameter. Here we install 3 rods and the diameter is 15 meter. You can see here this circular path is not protected all the roof. So in that case we will install 6 rods. When they overlap, the entire roof become protected. So as per our calculation, one rod covers 15 meter outside and 6.54 meter on the roof. So by installing 6 rods, we can fully overlap the cones and cover the whole roof, ensuring no part is left unprotected. So friends, that's how we calculate the design lighting protection using rods, spacing and protective zones. By applying these simple steps, you can make sure that your roof or equipment or people are always under safe coverage. So if you found this video helpful, don't forget to like, share and subscribe to my channel. Thanks for watching and we'll see you in the next video.